Looking at the periodic table that you have in front of you, right? Give me the elements that are in group 2.
Repeat.
Periodic table that you have in front of you. Give me the elements that are present in group 2. Or you have the periodic table in front of you. Which one?
Beryllium.
Yeah, man. So that's Be, that's one. What about the others?
Magnesium.
All right, good. Magnesium. What else?
Calcium.
Good. So we're gonna be looking at these three elements, right? And we're gonna be looking at the specific trend that they have whenever we're going down in the group. So we're gonna quickly be drawing the structures, and we're gonna be outlining the difference between the three elements. So remind me again, what's the mass number for Be and what's the atomic number?
Beryllium.
Yes. So what's the mass number? What's the atomic number for beryllium?
9.
So 9 is what? 9 is the atomic, or is it the atomic number, or is it the mass number?
Mass number.
Good, excellent. What about the atomic number now?
4. 4, sir.
All right, good. How many P, how many N? You remember?
Sir?
Do you remember how many P, how many N we have in the structure of beryllium?
No, sir.
Remember that the protons and the neutrons, they make up this number that we have at the top, which would be the bigger number, as we said before. The bigger number would be the mass number. I'm telling you that already. You should have an idea what the mass number is, and we did that already in one of our sessions. So you remember that? You remember that, Morgan?
Not really.
All right. Remember the protons and the neutrons give us what we deem as the mass number, right? And remember the atomic number tells what? Atomic number tells the amount of what in the structure again?
Neutrons. Neutron?
No, not it tells the amount of protons, right? So the atomic number, which is the one that you're seeing on the screen, which we're gonna find the R on right here, that's the amount of proton, right? So if this tells the amount of proton, how many proton would they have in the structure now?
4, sir.
Good, excellent. So we have 4, right?
5. 5
Yeah,
million.
yeah, man. So you get it now. Good.
Yes, sir.
So that's 5. So, and we said the first shell can hold a maximum of again.
2.
Excellent. So it can hold a maximum of 2. All right, we draw the 2 here. So, right. We have 2 here. So how much we have remaining can go on the second shell?
Sir?
All right. So we have 2 here. So how many we have can go on the second shell?
4. 4. The
No,
maximum.
no, man. Remember the atomic number tells the amount of protons, and it also tells the amount of electrons. So if this first shell has or replaced 2 on the shell, how many is remaining on the second shell?
2. 2, sir.
Good. So we have 2. And if we write in the EC now, what would be our EC now?
2, 2.
Excellent. So we have 2, 2, right? So that's beryllium. So we finish with beryllium now, right? Remember that we're looking at the trend. So let's see. Gonna draw everything, and we'll see what the trend is. So we're gonna draw magnesium now. What's the atomic number? What's the mass number of magnesium again? Give me the atomic number. Give me the mass number.
Atomic number 12.
Yeah, atomic number is 12. What about, hold on, give me a minute. All right, so the atomic number is 12. Good. What is the mass number now?
12 atomic number.
So the atomic number 12, what is your mass number?
20,
I didn't hear that. Go.
24.
Yeah, excellent. 24. So it's 24. Right? Now enjoying the structure, right? Remember, we'd have 12p, right? Because our atomic number tells the amount of protons. And we will also have 12n. Are you following what I'm doing so far?
Yes, sir.
All right, good. First shell can hold a maximum of 2, right?
Yes,
So
sir.
we have 10 remaining. We have 10 remaining out of the 12 to place on these shells. So remember the second shell can hold a maximum of 8.
8.
Yeah, so like I always recommend, you start out single first, then you start to pair. All right, so 8 and 2, that would give us what?
10.
Good. So how many electrons would be remaining now out of the 12? If we already placed 10 on the shells so far.
2. 2, sir.
Yes, good. So we have 2. So bam, that's 1. And we also put this 1. Now, looking on the structure now, what would be our EC?
2. 2A2.
Excellent. So this would be 2A2. So 2A2, right? And that would add back up to the 12. Now, moving on to the third one, then we're going to identify the trend that we're seeing, right? Which would be calcium. Now, give me the mass number, give me the atomic number.
Sir.
Give me the mass number for calcium. I already stated the atomic number at the bottom here.
Sir, mass.
Yeah, give me
Mass
this.
number.
Yeah, the mass number. So give me the mass number. I already stated the atomic number.
Sir, 40.
Yeah, excellent. So that's 40. Right, so that's 40. And then remember, the mass number is a combination of the amount of neutrons and the amount of protons.
Yes, sir.
20N and it's 20P.
Yes, sir.
So you draw in the structure now. Right, and in this case, we have space for 20 electrons. So we quickly draw in the structure. So 8 on the second shell. The second shell can hold a maximum of 8 as we outlined already in all our sessions. Right? So we have 8 and 2, that's 10. So we have additional of 10 electrons remaining. So the second shell at this level can hold a maximum of 8. Alright, if you do it at 6 form, then it's a different ball game. So that. Alright, so if we're supposed to count all electrons that you're seeing, right? How many electrons in total they're seeing on this structure?
20, sir.
Count it properly.
Which one is shell, sir?
No, I'm saying count the overall electrons that you're seeing and what the array is pointing on. The calcium structure right here. How many electrons in total you're seeing that we have drawn so far?
Oh. Sir, the RNA we can't see it so good.
I can see. Alright, so what we're seeing here in the structure, we have 2 on the first shell, which is this shell, right? Then you have 8 on this second shell, and we have 8 on the third shell, right? So 8 and 8, that would give us 16, and then an additional 2 would give us 18. So that therefore means we have an additional 2 more to place on the last shell here. Because remember, we have 20 in total. We have 20 electrons to go on the structure. So in this case, I put these on the last shell. Alright, so based on what you're seeing right now, are you seeing any trend that as it relates to these elements that we see in group 2?
Sir?
Are you seeing any trend as it relates to these elements that you're seeing in group 2? So the EC for this would be 2882. Yeah, man, are you seeing any trend? Like what
Yes, sir.
exactly?
Down the group.
Yeah, go ahead. I didn't hear that.
Sir, they increase.
What exactly increase? Yeah, on the correct part, but what exactly increase?
EC. The EC, sir.
It's not necessarily, yes, it does, but that's not necessarily the term that I'm looking for. I want it to be geared towards the shells because we're looking at electron shells as it relates to the electron shells, the trend. EC tells what again?
Sir?
What does EC tell us again?
The amount electrons will depend on the shell, sir.
All right, excellent. So we're going to use that knowledge now to arrive at the conclusion. So if we're seeing what's on these two shells on the first one here, so for beryllium, how many electron shells would beryllium have here? Right here.
In all, sir.
Yes, so many based on the
Four.
EC that
Four.
based on the EC that we have, how many electron shells would be on these on
Four.
this on this?
Four.
Hmm?
Four.
I don't hear that.
Four.
No man, look carefully. Remember, you just tell me say EC tell us the amount of electrons on each shell. So if we have two here, so and two here, so how many shells would this have in total?
Four, sir. Four.
Shells. We're not talking about electrons, shells we are talking about.
Oh,
Shells. EC
two.
tells us,
Two shell.
yeah, yeah, good, excellent. So we have two shells. So these have two shells. We could just write it down at the bottom here. So moving on to magnesium now. How many shells would that have based on the EC?
Three shell, sir.
Excellent. So we have three shells.
Oh, the shell increase each time.
Yeah, man, excellent. That's it. That more I forget. Yeah, man. So two shells, so three shells. All right, so that's three shells. And as it relates to this one, how many shells would this one have?
Sir?
How many shells would calcium have?
Oh, not magnesium. Magnesium, sir, or calcium.
Calcium, how many would calcium have?
Four, sir.
Excellent. So that four. So four shells. Based on the as it relates to electron shells, right? They increase down the group. So that's something that you need to take note of. So it increase down the group. So just make sure you write that down in your book. Make sure you jot it down somewhere. Make sure you screenshot it. Make sure you have it. So electron shells they increase down the group.
Yes, sir.
That's the electron shells. So the idea is that when you're looking at the periodic table, which element would come after calcium?
Sir, repeat.
Looking at the periodic table I have in front of you, which element comes after calcium? Comes after calcium. You seen it?
Sir, may I look? Sir. Scandium.
Alright, so the idea is that scandium would have an additional shell in its structure if we're supposed to draw it. But we're not going to draw it, right? We're just going to be focusing on the first 1 to 20 as I outlined before in our previous session. So the idea that more you have is that trends in group 2, as it relates to electron shells, they increase down the group. Electron shells increase down the group. Last week we would have looked at the atomic structure. Sorry, not the atomic structure, the atomic radius or the atomic radii. And remember that we outlined as well that it also increased down the group. So if we're supposed to look on these structures here, the addition of one electron shells make the distance from the center further as you go down the group. You see in the trend? Basically the circle get bigger.
Yes, sir.
Amen. So that therefore means that the atomic radius or the atomic radii would also increase down the group. You get that?
Yes, sir.
Amen. We're supposed to touch on ease of ionization, but that would take longer. That would go over into like 2 o'clock. But you say you have somewhere to go at 2. So I'm gonna ask if you do. As soon as I get back home, right, you're gonna read up on ease of ionization. So let me share my screen and then show you what exactly I'm talking about. So give me a minute. Alright, you see my screen now? Am I gonna see my screen?
No, sir. Yes, sir.
All right, good. So let me zoom in a minute. Let me zoom in a bit. All right, so remember to also send some things in the group as well as it relates to the periodic table, because remember that's the topic that we also part of the topic that we're doing in the session now. So trends in group 2, as you're seeing right here, right? I want you to look at ease of ionization. So read up on that, and then when we meet in our next session, right? We can go through it quickly. Okay.
Yes, sir.
All right. For those who are watching this video, again, don't forget to like, share, and subscribe, and can also book up your bit tutor. Also, if you want free study guides, customized worksheet, you can also reach out to us.